Well, welcome back to College Algebra. Today's lesson is on exponents. I'm sure you've all heard the expression talking about people saying things grow exponentially. Well, typically what they're saying when they say things grow exponentially is they're saying that they get really, really big, really, really quick. Now, that's not the case with every type of exponential growth, but for the main part, it's true and it's a good assessment, but it more than anything tells you what exponents can do. Now, I want us to look at just a basic parent graph for exponents, and let's just look at 2. 2 to the x. And I want us to just construct a t-chart here real quick. And from this t-chart, let's just think about what happens here. Well, let's start off with 0. All right, 2 to the 0 power. Well, anything to the 0 power, except for 0 itself, is 1. 0 to the 0 power is an indeterminate number. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. So what's happening here? We keep doubling, keep doubling, keep doubling. 2 to the fourth is 16th, and so forth. Now, if we work backwards, we're going to see that we go into having things each time. So 2 to the negative first. Well, a negative exponent just means you move. So it's 1 over 2 to the first, which would be 1/2. 2 to the negative second is equivalent to 1 over 2 to the second, which would be 1/4, and so forth. No pun intended there. All right, so anyway, let's look at what this does graphically here. All right, 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and I did not have room for the 16th, but you can imagine what happens there. So we scroll up, and there we have an example of an exponential growth. Now, let's look at a different scenario. Let's look at taking the negative of 2 to the x power. And I'm going to just extend out here. Okay, so we have the negative of 2 to the x. So what happens here is you're just going to be doing 2 to the x and then taking the negative of it. So 2 to the negative 1/2, I'm sorry, I'm saying that wrong. 2 to the negative second is 1/4. So it's the negative of that, so it's negative 1/4. 2 to the 0 would be 1, so it's the negative of that, which is negative 1. 2 to the first is 2, negative of that is negative 2. So, and you can see what would happen with the rest of them. So this takes that same graph and it flips it and it goes down. So this is y equals the negative of 2 to the x. And this is y equals 2 to the x. Now, I want to look at one that does something that you may not be thinking about, but let's go with -2, -1, 0, 1, 2, and I'll stop at 3. But let's do this for y equals 2 raised to the negative x power. So we've got 2 to the negative of negative 2. So that's the same thing as y equals 2 squared, which would be 4. Negative 1. Again, you're looking at 2 to the negative of negative 1, which would be 2 to the first, which would be 2. 2 to the 0 is still 1. 2 to the first, that's 2 to the negative first, which would be 1/2. 2 to the negative second, 1/4. And then 1/8 here. So what happens with this graph is it reflects about the y-axis. So that graph reflects about the y-axis. It should not have that hump in there, but that's with my creative artistic talents. Last thing I want us to look at on exponentials is y equals, and let's consider 1/2 to the x power. Well, y equals 1/2 to the x power. All right, we got 2 to the negative second, 1/2 to the negative second. Well, 1/2 to the negative second is the same thing as, again, you got the negative exponent, so they flip around to become positive. So it's the same thing as 2 to the second. 1/2 to the negative first is the same thing as 2 to the first. 1/2 to the negative 0 is the same thing as 1, because again, anything to the 0 power is 1. 1/2 to the negative, to the positive first. Well, that's just going to be 1/2. 1/2 to the second is 1/4. Again, you're raising both the numerators and the denominators to that exponent. And then 1/2 to the third is 1 to the third, which is 1 over 2 to the third, which is 8. So what we see here is that when we have 1/2 to the x, it yields the same results as y equals 2 to the negative x. So both of those equations are the same then. So this is a quick recap. I'm sure a lot of you have seen this before. You may have just looked at it in a different perspective. But this is what we're looking at as far as exponential growth is concerned. And anyway, see how that goes for you, and we will be back. Next lesson will be on logarithms. This was lesson 5.1. 5.3 will be on logarithms, and if you notice from WebAssign, the assignments are grouped together as 5.1 and 5.3.